Discuss PA56 part 2, that is session hijacking. So we have already talked extensively about the authorization code grant flow. To obtain an access token in this flow, the client needs to take an intermediate step involving the authorization server producing an authorization code delivered in the URI request parameter through an HTTP 302 redirect. This redirect causes the browser to make a request to the client, including the authorization code, as we have seen in auth code flow, right? So get/callback with the query code, that's HTTP 1.1, and the state parameter. The value of the authorization code is a one-time use credential, and it represents the result of the resource owner's authorization decision. We want to highlight that for confidential clients, the application basically that can securely store secrets like server-side apps, the authorization code is sent from the server to the user's browser, or you can say user agent. Since it travels through the browser, it may be saved in the browser history. That is true. So in the auth code flow, we have exchange of authorization code. We already discussed, and you know, right? So basically, it's just exchange of authorization code to get an access token. And now we are just trying to understand that authorization code generated from the ping-fed server and has been sent to the client through the browser. That means it is stored in the browser history also. This implies a potential security concern because sensitive information like the authorization code could be accessed if the browser history is not cleared or is shared. So let's see the scenario, right? In what scenario it can be hijacked, and what we can do here, how we can prevent it to be hijacked. So let's consider the following scenario. Imagine there is a web server, let's call it a site A, that consumes some REST API as an OAuth client. A resource owner accesses site A in a library or some other location with a shared computer. Site A uses the authorization code grant to get its OAuth token. This will imply that a login to the authorization server is required. As a result of using the site, the authorization code will remain in the browser history. That is true. So user is trying to access that site A, and then it just going to the authorization server, and you have the auth code, exchange of the authorization code, and that is stored in the browser. Okay. So when the resource owner finishes, they will almost certainly log out of site A. Let's say that user has done and just log out from the site A, and might even log out of the authorization server, but they won't likely clean their browser history. That means like maybe the user has done the logout, but the browser history is not cleared. And here we are talking about shared computer. So now an attacker logs in the website, that is site A, on a shared computer. User will just try to access site A on a shared computer. They find an old code saved in the browser. That is, I'm talking about authorization code saved in the browser from someone else who used the computer before. The attacker uses this old code to trick the website into thinking that they are the previous user. So as a result, the attacker can access the previous user's account or data even though they logged in with their own account. This happens because the website does not check properly who the code belongs to. We know, right, what is happening here. So what is the reason? So the browser history hasn't cleared. It's a shared computer. Another person came and like just some use the old code to trick the website into thinking they are the previous user. That means the attacker have access to the authorization code and then just use that and send to the website, right? And so basically, because why this happened? Because the website doesn't check properly who the code belongs to. That means I'm talking about website. It means attacker just try to send that code to the authorization server only to get an access token. And once you have the access token, you can call that you have the session of the previous user, and you can just it's just like it's a security concern, right? You can just get your data and all those things. So what's the solution to the problem? How we can just prevent it? If we are using a shared computer, in that case also, what can be the solution for this problem? So here the solution is the client must not use the authorization code more than once. If the authorization code is used more than once, the authorized server must deny the request and should revoke all tokens previously issued based on that authorization code. That means you need to apply the design here or the development here that the client must not use the authorization code more than once. If it's trying to use, an authorization server has to reject that. That means you already used the authorization code once, and if someone is trying to use again that, the authorization server has to deny. And not only deny, it should revoke also. The authorization server will just try to deny also and just revoke all the access tokens issued previously. Because here there is a chance of attack because it's already been used once. If someone else trying to use the same authorization code, that means something is there is some problem there. So in that case, the authorization server will just deny the request and just revoke the all tokens issued previously. Another protection for the authorization code grant type is to bind the authorization code to the client ID. So you can bind that code to the client ID, particularly for the authenticated client. What is the meaning of this line? That to improve security when using authorization codes, it's a good idea to link the code to the client application that we are saying the client ID. This is especially important for apps that are already authenticated. So what is the if we just bind, what is the advantage of that? In simple terms, you can say this ensures that the authorization code can only be used by the application it was issued to and not by someone else trying to misuse it. Because I just bind that code to the client ID, that means like it's just going to use only for that app that is entitled for. If someone else trying to use, it will not going to work. Right? So yeah, if you have seen also like in the industry also, the authorization code, like if you just try to experiment that also, you can see it will just fail. Right? So if you already use authorization code once and if you just try to use again the same authorization code to get an access token from the ping side or any other product also, you can see what is the result. It will deny because yeah, it's just a kind of attack. Okay, so this is basically the hijack like how you can hijack the authorization code. It basically for the shared computer only, but yeah, you can just put this action and you can prevent it. If someone can get that code also, it's just not going to work. Okay, so this is about that. In if you remember in the client section, the first vulnerability section, we talked about that code also, but yeah, there is a different way to hijack that. We talked about it through referrer. That's a different thing. And here we are just trying to see that yeah, on a shared computer, we are just trying to discuss on use case that how that keeping that authorization code in the browser, it can be a risk and how we can mitigate it. So I hope you are getting. If you have any question, please put in the comment section, and let's jump to the next one. Yeah, thank you.